states identify the effect of increasing acidity on the solubility of the given compounds. So drag the appropriate items to their respective bins. There are 2 bins, increase in solubility or no change in solubility. So I'm going to basically do a T-chart here. So it says here, I'll say increase solubility and no change in solubility. So you can say these 2 are our bins, right? So it says identify the effect of increasing acidity. So I have all these guys here, right? So I'm going to write them in blue. So I have calcium carbonate, CaCO3. I have calcium hydroxide. I have calcium sulfide, calcium phosphate, and then magnesium bromide, and sodium iodide. Okay, so I have all these compounds. It's saying identify the effect of increasing the acidity on the solubility of this compound, right? So let's look at calcium carbonate here. Calcium carbonate is simply a salt, right? It's made up of calcium and carbonate, right? So if I were to do an acid-base reaction here, I would have something like calcium hydroxide with carbonic acid would give me some type of salt here. And carbonic acid would be I believe it would be a weak acid. Let me just double check the Ka of carbonic acid. I believe it's either carbonic acid is indeed a weak acid. So yes, it's indeed a weak acid. So if I have a weak acid and I have a strong base, I will get a basic salt here. So this would be a basic salt. This here is a basic salt. Calcium hydroxide is obviously a strong base. And then I have copper sulfide. Copper sulfide here, I could get could be made up of it could be a neutralization of like copper hydroxide and of hydrogen sulfide. That could be a compound here. It's ionic. Calcium phosphate, I could have phosphoric acid and calcium hydroxide. Magnesium bromide is simply an ionic salt. I could have HBr and hydrobromic acid and magnesium hydroxide. Strong base, strong acid would give me an ionic salt. Same with sodium here. I can have hydroiodic acid and sodium hydroxide would give me ionic salts as well. So these 2 are all ionic salts. And calcium. So I have copper sulfide. I would have hydrogen sulfide HS and then a copper hydroxide. So I would have to find out what the Ka of hydrogen sulfide would be. Let's see. Hydrogen sulfide would be a polyprotic. So again, this would be a weak acid here. So let me see. Weak acid. Hydrogen sulfide is a weak acid. So weak acid with strong base. Again, I would have a basic salt. So here would be a basic salt here. And same with phosphoric acid. I believe it's also a weak acid because it does have a Ka value of, let me search up the Ka value for you. Ka value of phosphoric acid is 6.9 times 10 to the negative 3, which means it is a weak acid. I have calcium hydroxide as a strong base, which means I will have a basic salt for this one as well. Okay, so now I can define all of these guys here. So what does that mean? So when I increase the acidity on solubility of the compounds, then I would increase, if I increase the acidity, I would increase the solubility. So if I increase something that's a strong base already, it would, by acidifying that, the base, or if I'm increasing acidity, the solubility will also increase. You can think of it as a neutralization reaction here. So calcium hydroxide here, I would say this will increase its solubility. So I'm going to say here, this here is CaOH2. Same with the basic salts, right? So calcium carbonate, copper sulfide and sodium calcium phosphate here. The basic salts, if I acidify, if I increase the acidity, it will also increase the solubility, right? Because what I can do is I have calcium carbonate as a basic salt. I could add it with another acid in this case. So let me draw that out for you, and I'll use calcium carbonate as an example, and I'll do this in black. So to prove to you that it's a basic salt, again, I have calcium carbonate plus if I still have another acid like HCl, what it's going to do, I'm going to get HCO3 plus CaCl, right? And this here, HCO3 is our carbonic acid. So this here would make another acid, and this here would be our ionic salt, right? CaCl. So in this case, this proves to you that if I add an acid here, it will increase solubility here. So in this case, all my basic salts also go into this column here. So I can write basic salt would be also CuS, CaCO3, and Ca3PO4, and no change in solubility would be my ionic salts, right? Because these are products of strong base and strong acid neutralization reaction. So MgBr2 and NaI would not change in solubility. So let's look at our thing here. So increasing as it is basic, so acidifying good. Ca3PO4 is calcium phosphate, will increase because it's a basic salt, good. CuS is no change. CaCO3 is increasing. I don't know why they put CuS as no change here. Is it a basic salt? Because what I'm thinking about I'm not sure about this one because I put it here as a basic salt, right? So let me write down here because I thought of this this here. I have copper hydroxide, so CO, maybe copper 2 hydroxide here would be a base. Plus I have hydrogen sulfide, and I thought this was good. It's going to go to water and CuS here, but it would depend, right? I have copper hydroxide. I'll have to check the I would have to check the Kb of copper hydroxide. So let me just check that and see if this actually this reaction goes. Copper hydroxide. Yes, copper hydroxide is actually a weak. Oh, it's also a weak base. So that's why it makes sense. So I didn't actually tell. I assumed my hydroxide here was a strong base, but it's not. So this is a mistake on my part. So what I actually have here is I have a weak base with a weak acid, which means my CuS here, the pH would not really change here. So I would have, you can think of this as the same thing as an ionic salt. So that was my fault. I didn't check the Kb's. So this here, it does not belong here. It belongs to the ionic salt. So no change in solubility. So this is CuS. Because I assumed copper hydroxide, because of the hydroxide ion, is a strong base, but in reality it's a weak base. Maybe probably because copper is a multivalent compound. It has a +1 or a +2 charge. So that's probably my fault. My bad for that one. But here is our correct answer. And they didn't justify it so well in this case. But I would say great solution. However, would have liked to seen why CaCO3, Ca3PO4 I think it's just 2, are basic salts, products of strong base, weak acid neutralization, or reaction. We got reaction. Therefore, increased solubility when acidified. So yeah, solution here is correct.